If I asked you, what's something that's useful for taking care of fish, birds, dogs, mice, and pretty much any pet, what would be your first guess? Now, let's set aside the more technical stuff like antibiotics for a moment and talk about a hidden little gem, cuttlebone. As a byproduct of the cuttlefish, cuttlebone is commonly used as a chew toy for pets, especially small animals. But for some, it has more than just that one purpose. This stuff is porous, it's water-permeable, affordable, and it's a natural marine product. Put all that together, and it looks like it could be a solid choice for aquarium filtration. But is it really? How does it compare to coral skeleton, another marine product used for filtration? That's exactly what we're going to explore in this experiment. For this test, we bought some cuttlebone off Amazon, rinsed it, and broke it up to place it in the filter compartment of a 40-230 centimeters back filter tank. The counterpart for comparison is a similarly sized piece of coral skeleton. We've tested coral skeleton before, and based on the analysis, we found it has a smaller effective surface area, but decent water permeability. Now, let's see how these two perform as filter media. Both materials were placed in the same tank, with equal volumes of filter media, the same water volume, and the same model water pump and heater. We added 2 clownfish, fed them equal portions, and monitored water quality over time. After 30 days, we finally got the results.
Later.
Before we dive into those though, let me point out a few differences between the two materials. The cuttlebone we got had a faint fishy smell and floated on the water surface ice. Even though cuttlefish use it to achieve negative buoyancy in seawater, it just floats in our setup. And it stayed floating the whole time, even after soaking it properly. On the other hand, the coral skeleton had no noticeable smell and sank to the bottom. Some pieces also seemed a little darker. After a month of testing, here's what we found. Since this was a tank cycling test, let's look at the process of establishing the nitrification system. From the ammonia and nitrogen levels, the cuttlebone tank had a significantly faster rise and higher peak than the coral skeleton tank. This suggests that the cuttlebone released more organic material during the experiment. When we checked the nitrite levels, we saw that while the cuttlebone did establish a nitrification system, it did so more slowly than the coral skeleton. About the release of organic material, this might not be entirely the fault of the cuttlebone itself. The bigger issue is that cuttlebone isn't commonly used as a filter media, so no one's really processing it specifically for that purpose. Most vendors market cuttlebone for its amino acids and organic content. If it were processed more carefully, like firing or using chemical treatments, the organic matter release could be significantly improved. That said, why bother with all this? The cuttlebone we tested didn't show any remarkable qualities. As a chew toy, it's tasty, cheap, and effective. As a filter media, it does establish a nitrification system, but its performance was average, with issues like floating and organic matter release. Compared to alternatives like oyster shells, it's just not that impressive. If you still want to use it, I recommend regularly monitoring the water quality and avoiding adding livestock until the tank is fully cycled. And that's it for this fishbowl experiment. If you found this interesting or useful, please like, follow, and share. If you have thoughts or questions about this experiment or other aquarium-related topics, feel free to comment or submit your ideas. Let's keep exploring the mysteries of aquariums together. This is Fishboy Lab, and we'll see you in the next one.